This topic and video is going to be all about our indice rules. What's an indice? Well, it's something like this. I'm sure you've seen it before. 6 and a little 3. We could call this 6 to the power of 3. So we call the big number the base, and we can call this little number an index, hence the word indice. Indice is the plural of index. We can call the 3 a power. That's what I call it usually, 6 to the power of 3. Or we can call it an exponent. What 6 to the power of 3 means, it means 6 times itself 3 times. So 6 times 6 times 6. It does not mean 6 times 3. Common mistake. It means 6 times itself 3 times. And 6 times 6 times 6 is 216. So 6 to the power of 3 is 216. And this concept of indices can also be worked algebraically too, which we'll get to in a sec. Let's just look at indices numerically first. Let's look at this black section on top. Find the value of 3 to the power of 3. Well, we have to multiply the base, which is 3, by itself 3 times. So 3 times 3 times 3, which is 27. Here, we have to do 5 squared plus 2 to the power of 3. Well, 5 squared is 5 times itself 2 times, which is 25. And then we have to add that to 2 to the power of 3, which is 2 times itself 3 times, which is 8. And if we add them up, it makes 33. And that would be our answer. We can also use indices with variables. The letters are called variables. So a to the power of 3 times a squared, we have to simplify it. Well, a to the power of 3 means a times a times a, and we're multiplying this by a squared, which just means a times itself twice. So now we see it's a times a times a times a, which just means a to the power of 5. And you'll notice something. Whenever we multiply indices, first of all, the bases have to be the same. Very important. Make sure the bases are always the same. Whenever you multiply them, what we do is we add up the powers. 3 plus 2 is 5. So that's our first indice rule. When we multiply indices, we always add them up. Let me just take this away. So whenever we multiply, we always add the indices up. The next rule is the division rule. Well, a to the power of 6 divided by a to the power of 5. Let's draw this out. Well, a to the power of 6 means a times a times a times a times a times a. And we're dividing that by a to the power of 5, which means a times itself 5 times. Well, now we can cancel out the a's in common. So we can cancel out 1a, 2a, 3a, 4a, 5a. And there's just 1a left, so a to the power of 1. Or literally just a, but we'll put the 1 there just for reference. So what's the division rule? Well, when we divide indices, we subtract the powers. 6 minus 5 makes 1. And that's our second rule. So let me write the first rule down. A to the power of 3 times a to the power of 2. We add them up to make 5. For the next one, the division rule, we subtract them to make a to the power of 1, or just a. The next rule, a to the power of 5 to the power of 3. Well, we're basically powering a to the power of 5 3 times. So this means a to the power of 5 times itself 3 times. And we've kind of turned into a multiplication rule. And what's the multiplication rule? Well, we add up the indices. So a to the power of 5, so 5 plus 5 plus 5 means a to the power of 15. And here you'll see a connection. We multiplied the inside and the outside indice. So 5 times 3 makes 15. Okay? So those are the 3 basic rules. The multiplication rule, the division rule, and I'll call this the inside-outside rule. There's an indice on the in, there's an exponent on the inside, and there's an exponent on the outside. You multiply them. Let me show you a quick examples. So p to the power of 5 times p to the power of 2. Well, they're being multiplied, so we add up the indices, so p to the power of 7. The second rule is the division rule. P to the power of 10 divided by p to the power of 3. Well, the indices are being divided, so we're going to subtract the exponents. So p to the power of 7, and then p to the power of 3 to the power of 10. Well, there's an exponent on the inside, and there's an exponent on the outside, and we multiply them. So those are the 3 rules you have to know, okay? So now we can work on some harder problems. So let's try and simplify this. A to the power of 9 times a to the power of 2 divided by a to the power of 4. Well, let's first solve the top section. A to the power of 9 times a to the power of 2. This is the multiplication rule, so we have to add the indices together. So a to the power of 9 times a to the power of 2 will be a to the power of 11, and that's being divided by a to the power of 4. And our division rule, these two things both mean division, is we subtract the indices. So a to the power of 11 divided by a to the power of 4 will make a to the power of 7. Let's look at another example, harder one. Let's simplify this. Well, someone's like, yo, simplify this expression. Well, let's simplify this part first. Well, t to the power of 3 is being powered by 6. Well, there's an indice on the inside and an indice on the outside, so we're going to multiply those together. So t to the power of 18, and that's being multiplied by this thing. So there's an exponent on the inside, exponent on the outside. Sorry guys, I'm switching my words. I'll call them exponents from now on. All right. So the inside-outside exponent rule is t to the power of 4. And then we can use our multiplication rule where we have to add up the exponents. So t to the power of 22. Okay? And this is just called simplifying. We're not finding the value of t because it's impossible to find. We're just combining this big clump into one single term, okay? Let's look at this problem here. Find the unknown. B to the power of something to the power of 7 makes 21. Straight away, I notice this is the inside-outside rule. Something times 7 makes 21. Therefore, our unknown must make 3. Because b to the power of 3, I'll replace the unknown with 3. To the power of 7, the inside-outside rule is we have to multiply the terms. Therefore, our unknown must make 3. Next one is perhaps a little trickier. R to the power of 5 to the power of something divided by r squared makes r to the power of 33. So the first rule I see is there's an inside-outside rule. 5 times something. I'll write it out. 5 times something. And then the division rule. So division means subtract. Minus 2 should be 33. So I've kind of just ignored the r's and just written it out an equation based on the indices only. So the inside-outside rule. So 5 times something. So 5 times something. The division rule. Minus 2, because division means minus, makes r to the power of 33. And now it's just a simple algebraic equation. We can just reverse it. So 5 times something minus 2 is 33. We'll add 2 to both sides. So 5 times something is equal to, that cancels out. 33 plus 2 is 35. 5 times something is 35. Our unknown must be 7. Okay? And let's double check. Let's replace that question mark with, let's replace that question mark with 7. So r to the power of 5 to the power of 7. So the inside-outside, we have to multiply them. So r to the power of 35 divided by r to the power of 2. R to the power of 35 divided by r to the power of 2. Well, the division rule is subtract. So 35 minus 2 is r to the power of 33. So we were correct. Our unknown is 7. On the next page, guys, here's some practice. So the questions in black, you have 1, 2, 3, 4, 5, 6, 7 of them. You just have to simply simplify the expressions. And in the blue, you have to find the value of x, all right? So you have 3 questions, 1, 2, 3, and you got to find the value of these unknowns, okay? Very similar to the questions we were doing just now over here. All right, and then we'll get to the next section, all right? Gang, next set of indice rules. We have to do negative indices and fractional indices. Let's start with negative indices. Find the value of 4 to the power of negative 2. So now, when people think of negative indices, they just go, okay, it's going to be negative 4 to the power of 2. No, a negative indice means the reciprocal. The word reciprocal means the opposite. So if we're doing 4 to the power of negative 2, we have to find the reciprocal of 4. Well, what's the opposite of 4? It's not going to be negative 4. If we write 4 as a fraction, it'd be 4 over 1. So the opposite of 4 over 1 is going to be 1 over 4. And then the 2, the indice, it becomes positive and goes on the denominator. So 1 over 4 squared, and we can simplify that to 1 over 16. And that would be our answer. Next one, 7 to the power of negative 3. Well, I see a negative indice. We have to find the reciprocal of 7. Well, 7, the opposite of 7, well, 7 is 7 over 1. The opposite of 7 over 1 is 1 over 7, and the indice goes at the bottom. So 1 over 7 cubed. 1 over 7 cubed is 7 times 7 times 7. I think that's 243. Let's just double check. 343. And that's how you do negative indices. Let's make this more algebraic. Write as a fraction b to the power of negative 5. Well, same thing. I see a negative indice. A negative means reciprocal. B as a fraction would be b over 1. So we're going to swap that. 1 over b. And the negative becomes positive. 1 over b to the power of 5. Next, same thing. C to the power of negative 10. Negative means inverse. So opposite of c is c over 1. The opposite of that is 1 over c. And the indice goes at the bottom. And we've written, and the question was, right as a fraction. So we've turned b to the power of negative 5 into a fraction. Next is fractional indices. Find the value of 8 to the power of 2/3. This does not mean find 2/3 of 8. You just have to memorize 2 simple facts when we have fraction indices. We root with the denominator and we power with the numerator. So if I wrote this out, it would be 8. We're going to root it by 3, so the cube root of 8. And we're going to power that answer by 2. Or you can do 8 squared first, so 8 to the power of 2, and then cube root it. Doesn't matter what order you like to do it. I like to cube root first. So I like to deal with the denominator first. So cube root of 8 is 2, and 2 squared is 4. Next one, 25 to the power of 1/2. Well, I see a fraction to see, so we're gonna power by 1 and root by 2. So I write this out, 25. We're gonna root it by 2, which is just the square root. So we don't actually have to put that little 2 there. We assume it's just an invisible 2. And we're going to power that by 1, which we don't really need to do anyways. So the square root of 25 is 5. Let's simplify a to the power of 3/4, where we're going to root it by 4 and then power by 3. Last one, we're going to root t by 4 and power it by 1, which we don't need to put. And that would be our answer. So you root by the bottom, so 8 rooted by 3. Well, what 3 numbers make 8 is 2 times 2 times 2, which is 2. and we're going to power the answer. So 2 squared makes 4. Here, 25, we're going to root it by 2, which is just known as the square root. What two numbers make 25? Which is 5, and then 5 to the power of 1 is just 5. And then we can also combine negative and fraction indices. Find the value of 27 to the power of negative 2/3. So first things first is I'm going to deal with the negative indice. Well, from before, negative means inverse or reciprocal. So 27 as a fraction is 27 over 1, and therefore we flip it. So it'll be 1 over 27 to the power of 2/3. I have a fraction indice. So it'll be 1 over 27, root it by 3, and square the answer. So the cube root of 27, what three numbers multiplied by each other make 27 is 3. 3 times 3 times 3 is 27. And then 3 squared makes 9. So our answer is going to be 1 over 9. Next one, 4 to the power of negative 5 over 2. Well, I see a negative, so I'm going to inverse my value, 1 over 4. The indice becomes positive. So we're going to root 4 by 2. So the square root of 4. I'm going to power by 5. Well, the square root of 4 makes 2. So let's simplify it slowly. 1 over square root of 4 is 2. We're going to power that by 5. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, which is 1 over 32. And that's our answer. Next, let's make it algebraic again. So simplify negative 3 over 4. So I have a negative indice. So it becomes, well, t is t over 1. Negative means inverse, so 1 over t to the power of 3/4. So you can leave your answer like this, or you can leave it like this. 1 over t rooted by 4 to the power of 3. Same thing here. K to the power of negative 1/6. It's a negative, so we have to find the reciprocal of k. Well, k is k over 1. We're going to swap that to 1 over k to the power of 1/6. So we're going to root k by 6. I'm going to power it by 1, which we don't. When you power by 1, it's just going to be itself. So you can leave it with this answer or this answer over here. Now, on the next page, we have to also work backwards. Let's have a look at this question. The square root of a, and we have to write it as an indice. Well, I see a root. So first of all, I know it's going to be a, and there's going to be a fraction. Because when we have fraction indices, there's a root and a power. Well, a is being square rooted. When we square root, it's just an invisible 2. So we're rooting by 2. And is a being powered by anything? No, it's being powered by 1. So our answer is going to be a to the power of 1/2. This one here, well, there's k. I see a root and a power. This has to be a fraction indice. Well, k is being powered by 2. So a was being powered by nothing, so it's going to be an invisible 1. That's why 1 is our numerator. And square root means 2, so 2 is our denominator. And so we're powering k by 2, and we're rooting it by 3. And that's our answer. Next one, 1 over t to the power of 5. Well, I see that t is t over 1, and it's been flipped to 1 over t. So this has to be a negative indice. So t to the power of negative, and t is being powered by 5. So it'll be t to the power of negative 5. Next one, 1 over z. Well, I see that z is z over 1, and that's been flipped, so it's going to be a negative indice, and it's going to be a negative, and z is by itself, so it's basically to the power of 1, so it'll be z to the power of negative 1. Last two, sorry. 1 over the square root of y. First of all, I noticed an inverse. There's y over 1, and that's been flipped to 1 over y. So I know straight away it's going to be y to the power of negative something. Now, I see a root, so it has to be a fraction. Well, this is the square root of y. So what two numbers multiplied together make y? So the root has to be 2, and y is being powered by nothing, aka it's being powered by 1 itself. So y to the power of negative 1/2. Last one, well, I see that t over 1 has been flipped to 1 over t, so it has to be a negative indice. And then it's being rooted and powered, so it has to be a fraction. Well, t is being powered by 3 and being rooted by 4. So t to the power of negative 3/4. This is a super mega important concept, guys. It appears in many topics in shape, obviously indices, but also in quadratics and algebra. So make sure you're comfortable going backwards and forwards. And over here is, you can pause and try these practice questions. So the first section is about fractional indices. Second section is about negative indices. And the third section is about combining fraction and negative indices all together. And we'll get to another concept next. Thanks. Next section, guys, is simplifying indices with coefficients. What's a coefficient? Well, here's a term, x squared. X is called the base. The 2 is called the indice, or the index, or the exponent, or the power. And if there's a number being multiplied to x squared, like 6, so 6 times x squared, this is called the coefficient. It's the number being multiplied by the base. All right? And so we're going to be simplifying indices with coefficients now. Let's have a look at this simple indice again. So x squared times x to the power 5. From the last section, you should know when we multiply indices, we always add the powers. So x2 times x5 will be x7. What we're going to do is we're going to add some extra numbers in the front now to maybe make the problem a bit more spicy, all right? But it's pretty straightforward. Let's actually do this example. Let's simplify 3x squared times 4x to the power of 5. What I like to do is I like to split up the coefficient and the base and index like this. So 3, split it up, x squared, and then same thing here. I split up the 4 and the x to the power 5. And what I do is below, I'm going to write 3 multiplied by 4. So I'm going to multiply the coefficients first. So 3 times 4 is 12. And then I'm going to multiply the indices. So x squared times x to the power of 5. This dot means multiply. X squared times x5 is x to the power of 7. So the final answer is 12x to the power of 7. So that's all you do. You split up the coefficient and the index, and you combine the coefficients and multiply them, and combine the indices and multiply them. Let's have a look at these problems over here, right? I'll take this away. Simplify 3x to the power of 5 times g multiplied by 7x squared g to the power of 7. So what I'm going to do is I'm going to first separate the coefficient with each indice, and even I'll separate each letter. So 3x to the power of 5, and g, for the other term, it's 7x squared g7. So first I'll multiply the coefficients. So 3 times 7 is 21. X5 times x squared is x to the power of 7. And g is basically g to the power of 1 times g7 is g8. And so you just combine them. So 21, x to the power of 7, g to the power of 8. And this is your answer. Same thing here. 15, y to the power of 7, p to the power of 3, divided by 3 times y squared times p to the power of 4. So I'll separate my coefficient from the different indices. And this time I'm dividing. So I'm going to first grab my coefficients. So 15 divided by 3 is 5. Y7 divided by Y2. Well, our division rule is we subtract the indices, so Y5. And then finally, P3 divided by P4, P to the power of -1. So I combine them, it'll be 5 y squared P to the power of -1. So 5 times y to the power of 5, and P to the power of -1. And that's our answer. Next one, same thing. Separate the coefficient from the different indices. So 7, g cubed, c, and all that's being squared. I'm going to separate the coefficient from the different indices. Step 1, 7. So I'm going to do 7 squared. Well, 7 squared is just 7 times 7, which is 49. Then I'm going to do g3 squared. So g3 to the power of 2. The inside-outside rule is you multiply the indices. So g to the power of 6, and then c, and that's being squared. Oh, okay, so c squared. So now we just combine 49 g to the power of 6 c squared, and that is our final answer. Last one before we get to some harder ones. So I'm going to same thing. I'm going to separate my coefficients from the variable. So 9 to the power of 1/2. So 9 to the power of 1/2. Remember from the last section, we root by the bottom and we power by the top. So 9 root 2, which is basically the square root of 9, which is 3. And we're going to power that by 1, which is just 3. And then x squared is being powered by 1/2. And the inside-outside rule, you can just use your calculator. We just have to multiply these indices. So 2 times 1/2 is 1. So x to the power of 1, basically just x. So our final answer is 3x. So equals 3x. Let's go to the next page. Similar, but maybe a bit trickier. 64x cubed to the power of 2/3. Same thing. I'm going to separate my coefficient from my indice. And so it's going to be 64 to the power of 2/3. 64 to the power of 2/3. We're going to root by the bottom, power by the top. So 64 rooted by 3. So what times what times what makes 64? Just put in your calculator. You can literally just put this into your calculator if you want. But I'll do it without a calculator. So the cube root of 64 is 4, and we're going to power that by 2, which is 16. And then x cubed is being powered by 2/3. The inside-outside rule, so 3 times 2/3, you can use your calculator. That will just be 2, so x to the power of 2. Our final answer will be 16x squared. Next one. Oh, this one's getting saucy. 4g squared divided by 9g to the power of 1/2. Whenever you have a fraction and it's being powered, what you do is you have to power both the top and the bottom by 1/2. For example, let me show you an example. Imagine we have 1/9 to the power of 3. Another way you could write this is 1 to the power of 3 over 9 to the power of 3. So we're just powering both the top and the bottom by 3. So we can apply the same logic. Oh, I should have left it there. So 1 cubed over 9 cubed. 1 cubed is 1. 9 cubed is 729, I think. Yes. So what we can do is we're going to power the top by 1/2 and power the bottom by 1/2. So 4g squared to the power of 1/2 over 9g to the power of 1/2. So let's start with the top. So I'll simplify. I'll cut the top. So 4 to the power of 1/2. You can use your calculator. It'll be 2, and then g squared to the power of 1/2. The inside-outside rule, we multiply. So 2 times 1/2 is just 1. So just g to the power of 1, which is just g. So the top will be 2g over, and the bottom, very similar. 9g to the power of 1/2. So I'll cut it. So 9 to the power of 1/2. 3. And g to the power of 1/2 is just g to the power of 1/2. Because g is just g to the power of 1. So g to the power of 1 times 1/2. 1 times 1/2 is just g to the power of 1/2. So the bottom will be 3g to the power of 1/2. And then we can just simply divide. So 2, so we can cut it again. And we can divide. 2 divided by 3 is just going to be 2 over 3. And then g, which is basically g to the power of 1, divided by g to the power of 1/2. Well, division rule is subtract. 1 minus 1/2 is just g to the power of 1/2. Now we just combine these two things together. So our answer is 2/3 g to the power of 1/2. A better way you can write this is g to the power of 1/2 is our numerator. So 2g to the power of 1/2 over 3, just like that. Let's do the next question on the next page, actually. So we got to simplify this. This is actually a past exam question. 125 e to the power of 12 over 27 f to the power of 3. All of that to the power of negative 2/3. Oh, that's pretty saucy. Oh my gosh. First things first, I see a negative indice. Negative means reciprocal. Holy crap, how do I spell that? Reciprocal? Something like that. So if we had the number 2, the reciprocal of 2 would be 1 over 2, because number 2 is basically 2 over... Number 2 is basically 2 over 1, so we flip that to 1 over 2. So what we're going to do is we're going to flip this fraction, because we have to find the reciprocal. So it'll be 27f to the power of 3 over 125 e to the power of negative 2/3. And all of that is being powered by 2/3 now. So we flipped it, now we're going to make the 2/3 positive. And same thing, we'll start with the top. So if we have a fraction and it's being powered by something, what we do is we power the top by 2/3 and power the bottom by 2/3. Oh crap, I made a mistake. E to the power of 12. So yes, if we have a fraction and we're powering it, we power the top by 2/3 and power the bottom by 2/3. Let's start with the top. So 27 f to the power of 3 to the power of 2/3. We can cut this. So we'll do 27 to the power of 2/3 first. You can use your calculator if you have one. So, or remember we root by the bottom, so it'll be the cube root of 27, which is 3, and then 3 squared, which is 9. And then we'll do the f, so f3 to the power of 2/3. So the inside-outside rule is you multiply. 3 times 2/3 is 2, so f to the power of 2. So the top will be 9f squared. Let's do the bottom now. So the bottom will be 125 e to the power of 12 to the power of 2/3. Same thing, we'll cut it. 125 to the power of 2/3 is equal to, you can put in your calculator, that'll be the cube root of 125 is 5. 5 squared is 25. And then E12 to the power of 2/3. 12 times, it's the inside-outside rule, so we're going to multiply these. 12 times 2/3 is 8, so e to the power of 8. So it's 25 e to the power of 8. Well, 9 divided by 25 is just 9/25, so we can just leave it as it is. And then f squared and e to the power of 8, we can't actually divide those because it's different bases. So our answer just stays as it is. And that's how we simplify it fully. This is definitely a harder question. This is definitely like an A or an A-star level question. And so that's about it for simplifying. indices with coefficients. Hope you found that okay. I just want to draw your attention to one small section here. Writing, let's put this on the next page actually. Write 5x to the power of -2 as a fraction. A common mistake people do is this. They say, oh, there's a negative indice, so we're going to find the reciprocal. I'm just going to write the inverse, whatever. We're going to find the inverse. So they say 5x as a fraction is 5x over 1, so they flip it. 1 over 5x, and then the 2 becomes positive. That's wrong, okay? Here's why. When you look at this term, is the 5 being powered by -2? Or is it just the x being powered by -2? It's just the x that's being powered by -2. So you're only going to make x the reciprocal. So when we do this, we'll leave 5 as it is, and we're just going to deal with x to the power of -2 on its own. Well, x to the power of -2, well, x as a fraction is x over 1. So we're going to do 1 over x squared. So the answer will be 5 multiplied by 1 over x squared. 5 as a fraction would be 5 over 1. So now we'll just multiply the fractions. So 5 times 1 is 5. 1 times x squared is x squared. And that would be our answer. It'd be 5 over x squared, because the 5 is not being powered by a negative number. Let's look at this one. W to the W 10. Oh my gosh. 10w to the power of -3. Now I notice that the whole term is being powered by -3. So even the 10 is being powered by -3. So 10w, negative means reciprocal. All right, recip. So 10w as a fraction is 10w over 1. We're going to flip that to 1 over 10w. The 3 goes below, and that would be our answer. Because also the 10 is being powered by -3. So just be aware of the distinction between these two questions over here. On the next page, I'm going to add some questions for you to try, okay? Team, here are some practice questions you can do about simplifying indices with coefficients. All right, guys, the next part of indice rules is called writing numbers as a power of other numbers. These are fairly common questions you see in exams, especially more like A and A-star level questions. So we're trying to take your work to the next level. Make sure you have this concept nailed down. Let's start with the basics, and we'll get harder and harder as we go. So write each of the following in the form of 9 to n. So we have to write 81 in the form of 9 to n. All that means is 81 is equal to 9 to the power of what? Well, this one's pretty simple. 9 to the power of 2 is 81. So n would be, so 81 is equal to 9 to the power of 2. The next one, 9 to the power of n is equal to, 3 is equal to 9 to the power of n. There is a few strategies. Well, this one's a bit harder. 9 to the power of what makes 3? Well, 9 to the power of 1 is 9. 9 to the power of 2 is 81, but we want a smaller number than 9. One strategy I'm going to teach you guys is called the common base strategy, okay? The common base strategy dictates that we should always find a common base before trying to answer these problems. Remember, bases are the integers. Are the bases the same? No. So let's make the bases the same. In order to find a common base, try and think of a number that powers to make 3 and also powers to make 9. In this case, it's pretty obvious it's going to be 3. 3 to the power of 1 makes 3, and 3 to the power of 2 makes 9, and 9 is being powered by n. So this 9, which is just 3 squared, is going to be powered by n. Then 3 to the power of 1 is equal to, well, the inside-outside rule is we multiply the exponents. So 2 times n is 2n. Now, once the bases are the same, we can cancel them out. And we just left with a little equation. 1 is equal to 2n. So 2 times something is 1. Well, we can divide 2 on both sides. 1 over 2 is just 1/2. That cancels out. N is 2. So our answer would be 3 is equal to 9 to the power of half. Another way you could have solved this is just think of your indice rules. Another way to get from 9 to 3, 3 is just the square root of 9. And if you think back to your indice rules, the square root, well, since we're rooting, the indice has to be a fraction. Square root means we're rooting by 2, so to the power of 2. And 9 is just being powered by nothing, so powered by 1. So that's another way you could find the answer is 9 to the power of 1/2. So you can either use the common base method or just try and think about the fact that the square root of 9 is just 3. I like to use the common base method because it works on most questions. Next problem, 27 is equal to 9 to the power of something. So 9 to the power of 1 is 9. 9 to the power of 2 is 81. How do we get to 27? Let's find a common base. So let's think of a number that powers to 27 and powers to 9. Well, this one, it's also 3. 3 to the power of 3 is 27. 9 is 3 to the power of 2. And this 9 is being powered by n. So we'll power this by n. So this is just 3 to the power of 3. The inside-outside rule is we multiply the exponents. So 3 to the power of 2n. Bases are the same. 3 is equal to 2n. So 2 times something is 3. We can divide 2 on both sides. 3 divided by 2 is 1.5, or just 3 over 2, equals n. So 27 is equal to 9 to the power of 1.5, or 3 over 2, however you want to answer it. Let's go to the next page and bang these questions out. It's going to get a little harder. 32 to the power of 4 is equal to 2 to the power of something. So let's write it out. 32 to the power of 4 is equal to 2 to the power of something. All right, our bases aren't the same, so let's make it the same. What's a number that can be powered to make 32 and be powered to make 2? Well, it's just 2. Using our calculator and using some trial and error, I know 2 to the power of 5 is 32. And 32 is being powered by 4. And that's going to be 2 to the power of x. Inside-outside rule, 5 times 4 is 20. So 2 to the power of 20 is equal to 2 to the power of x. Bases are the same. Look, 20 equals x. So 32 to the power of 4 is exactly the same as 2 to the power of 20. Next one, 25 to the power of negative 2 is equal to 5 to the power of x. So bases, they aren't the same. Let's make them the same. Well, the common base is going to be 5 because 5 squared makes 25 and 5 to the power of 1 just makes 5. So 25 is basically 5 squared, and that's being powered by negative 2. And here it just stays as 5 because our base is 5. Inside, outside, we multiply. So 2 times negative 2 is negative 4 is equal to 5 to the power of x. The bases are now in common. We can cancel them out. So negative 4 equals x. This would be negative 4. Next one, oh damn, it's getting tricky. 16 negative 4 over 4 equals 2 to the power of something. Let's find a common base. Well, 2 to the power of 4 is 16 and 2 to the power of 1 is 2. So our common base will be 2. 16 is basically 2 to the power of 4. That's being powered by negative 4 over 4 is equal to 2 to the power of x. Inside-outside rule, we multiply. You can just use your calculator. 4 times negative 4 over 4 will be negative 4. All right, 2 to the power of x. Bases are the same. Negative 4 equals x. Negative 4. Next one. 27 to the power of 5 over 3 is equal to 3 to the power of something. Bases aren't the same, so let's find a common base. What number can be powered to make 27? And what number can be powered to make 3? Well, 3. 3 to the power of 3 makes 27, and that's being powered by 5 over 3. And here our base is already 3, so we can leave it as it is. Power of x. Inside outside rule. We multiply 3 times 5/3 is going to be 15. So, 5. So 3 to the power of 5 is 3 to the power of x. Cancel out the common base, so 5 equals x. This is 5. So these are A-level question, guys, but once you know the strategy, it's actually pretty straightforward. But it's going to get, oh crap, it's going to get a little tricky soon, actually. I spoke too soon. 1 over 9 squared equals 3 to the power of something. Let's have a look at our base. Our base is 3. Our base is 9. Is there a number that can be powered to make 9? And is there a number that can be powered to make 3? Yeah, it's 3. So we can rewrite 1 over 9 as 1 over 3. Well, 3 to the power of 2 is 9. And that's being squared is equal to 3 to the power of x. And then, I see that 3 squared has been inversed because 3 squared as a fraction is 3 squared over 1, and now it's 1 over 3 squared. So we have to have a negative indice. So another way of writing 1 over 3 squared would be, leave it as red, would be 3 to the power of negative 2. Because remember, negative means inverse. So 3 to the power of negative 2 would be 1 over 3 to the power of 2. So 3 to the power of negative 2, and all that is being squared, and that's equal to 3 to the power of x. And the inside-outside rule is we multiply them. So negative 2 times 2 is negative 4. So 3 to the power of negative 4 is equal to 3 to the power of x. The bases are the same. We can cancel them out. Negative 4 equals x. And that's going to be negative 4. Last one, we'll do this on the next page. Sorry. 256 to the power of 5 over 2, I'll write it nice and big. Power of 5 over 2 is equal to 4 to the power of something. So same thing. Is the bases common? No. Let's find a common base. Is there a number which we can power to make 256? And is there a number we can power to make 4? Yes, it's 4. 4 to the power of something makes 256. I'll use my calculator. It's trial and error. 4 to the power of 4. I knew that. And 256, which is basically 4 to the power of 4, is being powered by 5 over 2 is equal to 4 to the power of x. 4, well, inside-outside rule is we multiply. 4 times 5 over 2 is going to be 10. It's 4 over x, power of x. Bases are the same. We can cancel them out. 10 equals x. Cool. Let's move on to some harder problems. All right, gang. Next page of questions. Some of these questions will be about the same. Some questions will be a little harder. So given that 4 to the power of n equals n, find the value of n. So 4 to the power of something equals 8. So same thing. Let's look at our bases. 4 and 8. Are the bases the same? No. Let's think of a number that can power to 4 and that can also power to 8. Well, this was just 2. 2 to the power of 4. 2 makes 4, and that's being powered by n. And 8 is basically 2 to the power of 3. 2 to the power... Now we can use our indice rule, the inside-outside rule. We'll multiply the inside-outside exponent. So 2n equals 2 to the power of 3. Cancel them out because the bases are the same. 2n equals 3. 2 times something is 3. N is 1.5. Next one. Given that 4 to the power of negative n equals 32, find the value of n. Okay. It's the same thing. Let's find a common base. So what number can power to 2 and also power to 32? It's 2. So 2 to the power of 2 is 4, and that's being powered by negative n. And 32 is basically 2 to the power of, use my calculator, it's to the power of 5. The inside-outside rule, so let's simplify. Inside-outside is multiply, so 2 times negative n is negative 2n is equal to 2 to the power of 5. Ooh, the bases are the same, we cancel them out. Negative 2n equals 5. Negative 2 is being multiplied by n. We'll divide by negative 2 on both sides. So n is equal to negative 2.5. Next one. Given that 3 times root 3 equals 3 to the power of n, find the value of n. So 3 times root 3 is equal to 3 to the power of n. Let's look at our bases first. Well, they're all the same. Okay, that's good. But this is an indice. This number is not written as an indice, and this number doesn't have an indice. So 3 is basically 3 to the power of 1 times this. This is the square root of 3, so it has to be 3 to the power some sort of fraction because we're rooting it. Square root means what two numbers make 3, so that it's rooted by 2, and 3 is being powered by nothing, so it's 3 to the power of 1. So the square root of 3 is basically 3 to the power of a half. You should know this from the last sections. Is equal to 3 to the power of n. Then we can use our the bases are the same, so we can use our multiplication rule. Whenever you multiply indices, you add them up. So 1 plus 1/2 is going to be 3 to the power of 1.5 is equal to 3 to the power of n. And then you can cancel the 3's out. So n is equal to 1.5. Last few questions. Given that, and these are the harder questions. Given that 2p, 2 to the power of p, times 8 to the power of q equals 2 to the power of n, express n in terms of p and q. When the question is asking to express n in terms of p and q, that means we have to make n the subject. So get n by itself. Let's write out our expression. So the first thing I noticed is that this is part of the indices topic. So then there 2 is being powered by p, 8 is being powered by q, and 2 is being powered by n. So first things first, I want to look for a common base because our base is 2, 8, and 2. So let's find a number that powers to make 2 and find a number that also powers to 8. In this case, our common base can be 2. So our first term can stay the same, 2 to the power of p times 8. We have to rate 8 as a power of 2. 8 is basically 2 to the power of 3. And that's being powered by q is equal to 2 to the power of n. Let's simplify this middle term. Inside, outside, we multiply. So 2p times 2 to the power of 3q equals 2 to the power of n. Now the bases are the same. Now we can multiply the terms. Whenever we're multiplying indices, we add up the indices. So 2p plus 3q will just be p plus 3q is equal to 2 to the power of n. Now the bases are the same, we can cancel them out. So p plus 3q equals n. We've got n by itself. So we've written n in terms of p and q. Next page, we have to solve for x. 6 times 2x plus 2 equals 24. So 6 times 2 to the power of x plus 2 is 24. Well, this whole section here must be 4 because 6 times 4 is 24. So I can write it out. So x plus 2 must be 4. Our bases aren't the same, so let's find a common base. Our common base can be 2. So 2x plus 2. 4 is the same as 2 to the power of 2. We can cancel out the common bases. X plus 2 is 2. Something plus 2 is 2. X is 0. That's our first one. Next one. 4 times 5x equals 500. 4 times, let's chunk all this together. 4 times something is 500. Well, 500 divided by 4 is 125. So 5x must be 125. So 5 to the power of something is 125. This is pretty easy. X must be 3. 5 to the power of 3 is 125. That was pretty straightforward, that one. 7 times 1 over 3 x equals 63. So let's chunk all this together. 7 times something is 63. This whole section must be 9. 1 over 3 power of x is equal to 9. Now let's find a common base. Our common base can be, well, our base here is 3, our base here is 9. Well, 3 to the power of 1 is 3, and 3 to the power of 2 is 9. So for the first term, it's just going to stay as 1 over 3 to the power of x. And 9 is basically 3 squared. Now, 1 over 3, we can rewrite that as 3 to the power of negative 1, because 3 has been inverse to 1 over 3. So 1 over 3 is the same as 3 to the power of negative 1. And then that's being powered by x is equal to 3 to the power of 2. Inside outside rule, we multiply. So negative 1 times x is 3 to the power of negative 1x is equal to 3 to the power of 2. Cancel that out. Negative 1x equals 2. X is being multiplied by negative 1. We can divide by negative 1 on both sides. X is equal to 2 times divided by negative 1 is negative 2. And then last one, 5x to the power of x minus 1 is equal to 1 over 25 power of x. Very similar. Our base is 5, our base is 25. Let's make both our bases 5, because 5 to the power of 1 is 5. 5 to the power of 2 is 25. So 5, this stays the same. X power of minus 1 is equal to 1 over 25 is 5 squared. And that's being by x. So 5x to the power of negative 1 is equal to 1 over 5 squared is basically the opposite of 5 squared over 1. So we can write 1 over 5 squared as 5 to the power of negative 2. All right? And that's being powered by x. Make sure you're well aware of your negative indices. Then we'll simplify this. Inside, outside, we multiply. So 5x minus 1 is equal to 5 to the power of negative 2x. Cancel out the bases. Ooh, now we have a little equation, x minus 1 equals negative 2x. Well, maybe we can add 2x on both sides. X plus 2x is 3x. So 3x minus 1 is 0. Add 1 on both sides. 3x equals 1. Divide 3 on both sides. So x is equal to 1/3. And that's our answer. Last one, this is a former GCSE question. Let's work through it together. It's very similar though. Actually, yeah, we'll do this one together. So 3 times 4 2k plus 8 equals 24. So 3 times all this stuff is 24. Well, 3 times 8 is 24. So we can say 4 to the power of 2k plus 8 must make 8. Next, let's look for a common base. Well, it can be 2, because 2 squared makes 4, and 2 cubed makes 8. So 4 is basically 2 squared, and all that is being powered by 2k plus 8. And then 8 is basically 2 to the power of 3. Then inside-outside rule, we multiply that. So 2 times 2k will be 4k, and 2 times 8 will be positive 16. And that's equal to 2 to the power of 3. Ooh, our bases are the same. We can cancel it out. 4k plus 16 equals 3. Solve this as minus 16 on both sides. 4k is equal to, that cancels out. 3 minus 16 is negative 13. Divide by 4, divide by 4. K is equal to negative 13 divided by 4. And that's it for indice, guys. That's one of the harder questions in the exam. That was question 20. So definitely like an A or A star level question, but it's very doable as long as you know your indice rules. So get your indice rules super down, fractions, reciprocal indices, negatives, whatever. And on the next page, I'm going to show you some work you can practice on these kind of questions. Okay, so here's some work for you guys to try. Make sure you definitely have this section down here, really important. And also, I'm pretty sure you can give these questions a try. You should have all the information you need to solve these problems. On this side too, give these a try. Oh, I don't think I've actually shown you how to do these questions here. Well, let's just do this one quickly. So given that 3 to the power of negative n equals 0.2, find the value of 3n squared. Well, first things first, I want to first find the value of 3 to the power of n. I only know 3 to the power of negative n. Well, what we can do is first we can turn this number into a fraction because when I have a negative indice, it means reciprocal. So if I was to flip 0.2, well, 0.2 is 0.2 over 1. I can flip that to 1 over 0.2. So 3 to the power of n, we're going to flip it to 1 over 0.2. That's kind of confusing. What we can do is before I start the question, I'll turn 0.2 into a fraction. 0.2 is basically 2/10, which is also 1/5. Now, if I find the reciprocal of that, it'll be 3 to the power of n. We'll flip that. 1 over 5 will turn into 5 over 1, which is just 5. Now, if I know 3 to the power of n is 5, now all I have to do is square that. So I just got to square that. So all I have to do is 5 squared. And 5 squared is 25. Sorry, I don't think I showed an example like that. But try the rest of these questions. Give it a pause. I'll make it bigger for you. Okay. Ignore that. And yeah, let me know if you have any questions. Thanks.